All right, loves. Here we go. The fundamental identities. They're fundamental because they are fun. Here we go. Yeah. All right. We've already talked about the majority of these identities before. I'm just putting it all on one sheet of paper for you. You're welcome. Here we go. Cotangent is 1 over tan. Hello. Secant is 1 over cosine. Hey. And cosecant 1 over sine. Right? Yep. Those are called the reciprocal identities. All right. Big one, a big one, right? I would definitely highlight this box in particular because this one comes up a lot more than the other ones. Tangent is what over what? Sine over cosine. If you don't remember, tropical smoothie cafe. That's interesting. That's interesting. Do we need, okay. Here we go. And cotangent is the flip. So cotangent is cosine over sine. Yes. Okay. Second and the most important formula, I would say, this is like the big one. The big one. I will put it in red because the buck stops here. Yes. What did you think I said? Here we go. Yeah. All right. All together, sine squared plus cosine squared equals. Only one person knew that answer. All together, sine squared plus cosine squared equals 1. It's 1. Uno. Yeah. There it is. Oh, it's got it one way. It's good. Sine squared plus cosine squared is 1. Yeah. Okay. All right. Those two in the red and blue are probably the most used ones ever. The rest of them can be used as well. Okay. If you take the sine squared plus cosine squared over 1 and you divide everything by cosine. Okay? This is where I talk about manipulating in your head. Divide everything by cosine. So this would be sine divided by cosine. What's sine divided by cosine? Tangent. Cosine divided by cosine is 1, and 1 divided by cosine is secant. So you would get this formula. Tan squared plus 1 equals secant squared. So if you divided everything by cosine squared, sorry about that, you would get that next formula. Right? It's manipulating in your mind. Do you want to do it again? Let's do it again. This is mental, man. This is mental. All right. Instead of dividing everything by cosine, divide it by sine. Sine divided by sine is 1. Cosine divided by sine is cotangent. And 1 divided by sine is cosecant. So 1 plus cotangent squared equals cosecant squared, love. Yeah. I know. Okay. Here you go. I think I messed up some of the other ones. I just want to make sure we're good to go. Negative angle identitos. Okay. The sign of a negative. Sine is an odd function. If you think about it, it starts at the 0, right? So when it does that, it's not symmetrical, so that makes it odd. So if you have a negative angle, all you do is pull out the negative and put it in front of the sine. That's it. So sine of a negative angle is just negative sine of that angle. Same thing for cosecant. Yay. Same thing for tangent and cotangent. You just pull out the negative. Yeah? Cosine is slightly different because cosine, right, this is cos, starts over here, right? That's cos, and continues over here. Since it's symmetrical, if you split it in half, since it's symmetrical on that side, it's an even function. So no matter what, if the x is negative, the y will always be positive and vice versa. So for this one, right, cosine of a negative angle, and I didn't mess that up, cosine of a negative is positive cosine. So negative angles don't mess up cosine. Yeah, same thing for secant. Right. Okay. Here's what I'm talking about manipulation. Sine squared plus cosine squared equals 1. Right? You must be able to manipulate that in your head and see it in a different form. Here's all you have to do. If you take away sine from both sides, if you subtract sine from here, you're left with cosine squared equals 1 minus sine. Yeah, oh, sorry, same thing. Same thing. So you can solve for sine and you can solve for cosine. Yeah? Okay? And the beautiful thing is you can substitute that form into a different part of the equation. I know. I love proofs. I don't know if I told you this. I'm going to tell you this every day. I don't like graphing so much, but I love me some proofs. You like graphing? Graphing's not bad. Yeah. Okay. She did great. She did great. Yeah. All right. And when I say proofs, are you thinking geometry? And you have to like side angle side and blah, blah, blah? Yeah. This proof is more of an algebraic proof where you kind of manipulate it through algebra. That's all a proof is. Manipulating it through algebra. Okay. All right. Here we go. Oh, wait a minute. What is this? This is not what I meant to do. Is this right? Nope. Nope. Did I switch out? Yep, I did. Okay, so here's what I'm going to do. This is not the right one. Okay. Nope. We go up here. Sorry about that. Was it the B? Yup. Huh? There it is. Okay. I did switch it around. I apologize. You get it. Okay. It's gonna happen. Apple pear. Apple pear? I got a pineapple. Oh, there's my old class. Aww. Oh, look at that shiny corny. Nice. What? There it is. Okay. Joy to the world. All right. Here we go. Okay. So, once upon a time, I made you draw a quadrant, and you had to draw the triangle in the quadrant, right? If worse comes to worse, go ahead and draw yourself a quadrant just to solve the problem. But let's expand our skills now because we got these identities and you can use them so many ways, right? So I'm going to solve these just by using identities. No triangle intended. All right, so you don't have to draw a triangle. Here we go. We're in quadrant 4, right? So what is positive in quadrant 4? Cosine and? Cosine and? Yeah. All right. So cosine and secant are positive. So sine is going to be negative, right? And tangent is going to be negative as well. Secant is going to be positive, and you'll see why in a second. Okay, so first, know what quadrant you're in because your answer is going to determine this. Okay, here we go. Solving this without drawing a triangle. Ready? Okay. If we have cosine squared, we have this beautiful formula that says sine squared plus cosine squared is equal to 1. All right, here we go. Okay. So sine squared plus cosine is 5 over it squared is equal to 1. True? Okay. Here we go. So squaring the 5 over 8, you have sine squared plus 25 over 64 is equal to 1. Right? And as long as I know in my head that 1 is 64 over 64 is true, that means sine squared is equal to 64 over 64 minus 25 over 64. True? Just subtract the 25 or 64 from both sides. Are you alright? Alright. Here we go. 64 minus 25. Yeah. What is it? Okay. It's 39 over 64. Now, if you remember back to Algebra 2, to solve a square, just square root both sides. But don't forget the plus or minus, right? When you take the square root, can you take the square root of 39? Heavens no. But you can't take the square root of 64. So it's 39 over 8. Is it the plus or the minus, though? It's the minus. It's the minus. So sine is negative root 39 over 8. Yeah, because you're in quadrant 4. Question. Why did you put the plus or minus? Because like if you don't figure out the negative at the end, at the beginning, then you want to keep both options open until you figure out, are you in quadrant 4 or are you in quadrant 1? Yeah. Leave them both up there, but circle the negative once you know which one's the answer. Because it can't be both. Great. Yeah. Yeah. It's a good time. So final answer, sine theta is equal to negative root 39 over 8. Okay? Now, had you drawn the triangle, this would have been x squared plus y squared equals r squared too. You could do it that way. Same thing, same thing. Just want to expand. Let's expand. All right. It's what? Did I just hear wine? Here we go. Like some cheese to that one. All right. Okay. Since we know cosine and we know sine, this should help us with tan, eh? Because isn't tan just sine over cosine, right? So watch this. Mind blown, right? Sine is negative root 39 over 8. Cosine is 5 over 8. Yeah. They're all related, right? Here's the deal. Both the top and bottom have a denominator of 8. So you can cancel it out. So tan is negative root 39 over 5. We're in quadrant 4. Is that a possible answer? Yes. Yeah, because tan is negative. There you go. There you go. I like it too. It's so easy. Okay. Same thing. Except this time we have secant of the negative angle. Remember that secant is an even function, so this is the same thing as secant theta, right? Secant theta is 1 over the cosine, so that means that's 1 over 5 over 8, right? So, I know I keep saying keep, change, flip, but I still get like that questioning look in people's eyes. Keep the first one, change division to multiply, and then flip the fraction. So 1 times 8 over 5 is that. Keep, change, flip. Okay? So what's secant? It's 8 over 5. And is it supposed to be positive? Yes. Yo. It is. We're quadrant 4. Quadrant 4 is cosine and secant. Wow. Wow. Gosh. I know. How do you feel? Confused. It's okay. The more you practice, the better. It's manipulation. Can I answer a specific question? So how do you do it with a what?
How do you know if it's cosine or not?
How do you know if it's cosine or not? It says at the top. Yeah, it like tells you in the problem. I'm just giving that to you because I feel like you can't see what you're bored. So I'm giving that to you in advance, yeah? Okay. Yeah, let's keep going. Let's keep going. All right, here we go. Expressing one in terms of the other. Yay? All right. So this is expressing tangent in terms of cosine. That means nothing in your equation can have anything but cosine. Yeah. Okay. Here we go. It's good. It's going to be good. I promise. Okay. Here we go. Tangent. Right. Tangent has this formula that says tangent squared plus 1 is equal to secant squared theta. Yeah. I'm going to keep the thetas out just for writing purposes, right? So there's that beautiful formula. Yay? Okay. So here we go. Since I want to express tangent, I need to find a formula for tangent that just has cosine. Got to solve for tangent. How do you get the tangent by itself? Subtract 1. Very good. So tangent squared is going to be secant squared minus 1. Yeah? Yeah. Okay. Yeah? All right, I'm almost at tangent. Almost got tangent by itself. All you got to do is square root both sides. Okay? Now be careful. Here's the key. And this is why, like, you would miss this question in Algebra 2 from me and Craigie. I know for sure. You must put what in front of the radical? Plus or minus. Because there's two possibilities. It's plus or minus. Okay? Square root of. Okay. Secant squared. Secant is what over what? 1 over cosine. Remember, the goal is to just get cosines. So on this side, I want nothing but cosines. That's it. So this is 1 over cosine squared minus 1. Okay? Fleck, what are you doing? All right, I got you. Here's the deal. Too messy. You can't have fractions in a radical. I know. It's crazy. Here we go. If you think to yourself and say, Sales, this 1 is just cosine squared over cosine squared, right? Yeah, because in order to add and subtract fractions, you need a common denominator. So my common denominator is going to be cosine squared. Is true? Okay. So this is equal to plus or minus the square root of 1 minus cosine squared all over cosine squared root. Not yet. Don't like fractions in a radical. What can I take the square root of? The cosine at the bottom. So, final answer. Ready? All in terms of cosine. It's plus or minus the square root of 1 minus cosine squared theta all over cosine theta. All right, I'm going to pause right here. I'm going to pause right here till we catch up. It's okay. Yeah, I'll pause right here. Yeah. Why is it just cosine? Because that's what the problem said. Right? Problem says, give me tangent as a function of just cosines. That's it. So you have to manipulate till you just get cosine. The bottom. Yes. But the one at the top, you can't take the square root of something that's got a minus in between it. Because that's an expression, right? So you can't just take the square root of that one. If it's got a minus in between, you just can't take individual square roots. Miss Sierra. Get? Yeah? Yeah. It's a good time. It's a good time. Yay? William, check my math. Is that right? Is that the same answer? Tan da 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 da. Okay. Put a star next to this problem. You'll definitely be coming back to this one. All right? Yeah. Okay. All right. Now, stop it. Here we go. Last example, and then it's practice, practice, practice. All right. The more you get done in class, the better, because I'll be here to answer your questions. I won't be here after school today because I got to go to my kids' Halloween party. So if you need any extra help, now is the time to get it. All right. Yes, love. Oh, the backside? That's all of chapter 5. So we're going to keep on filling that out. Yeah. Yeah. Yeah, it is sensational. Thank you. Okay. Here we go. Again, manipulation. Manipulation. Okay. This one says, if I gave you the expression secant squared plus cosecant squared, can you give it to me in terms of sine and cosine? Easy. Easy. All right. Here we go. Oh, I feel like you know what you're doing. Okay. Here you go. Secant is 1 over, you heard it, 1 over cosine, right? Isn't secant just 1 over cosine? And cosecant is 1 over sine. Okay, here we go. Adding and subtracting fractions. You need to get a common denominator. Okay, so to get a common denominator, and I know this was like one of the harder sections in Algebra 2, was doing rational functions. To get a common denominator, basically all you do is make sure the denominators have all the same pieces to it. So this one has a cosine, this one has a sine. So this denominator is going to need the sine. Whatever you do to the bottom, do to the top.
Oh, I remember this.
This one has a sine, it needs a cos. So multiply by cosine, whatever you do to the bottom, do to the top. You see it? What's my common denominator? Sine, cosine. Yeah. So sine theta, cosine theta, right? Once you have a common denominator, you just add what's on top. So top is sine times 1, which is sine. And then 1 times cosine, which is cosine. Did we fulfill the requirements of this question? Yeah. Everything is in terms of just sines and cosines. That's it, loves. That's it. Okay. That's it. William, check on me. Is that the answer? Yeah? Okay. All right. Here we go. Keep this sheet in front of you. In front of you. Okay? Keep that in front of you. Open your books. If you don't have a book, I have extra books so you can share with somebody. Open your book to page 204. Right? Start practicing now. I do not expect you to have homework for Halloween. Okay. Here we go.